All right, folks, so we are coming back in this lecture video and we're talking about how to generate a calibration curve based on the laboratory data that we obtained. But the problem here is that the lab data is not actually together one after another, nor is it side by side. There's like a weird little column in here that makes it odd and in a strange place. We can do calibration curves though the exact same way. We just got to know how to handle these. And I'll show you a trick that I do. It might not be the fastest. It might not work for you. You might hate it. You might know of a different method better. But I'm going to show you what I do just because I think it works for me. And I've never been let down by this method. So we need to do a cal curve with data that is separated. So what I'll do, like before, I will click on 50/50. I'll hold the control button on the keyboard. CTRL, control. All right. So 50/50, and then I'll click on the average that I want to bring in. I just select really random numbers here. I know I'm going to modify it a little bit later, but I'm just selecting two numbers so that way I can at least get Excel to build some type of a chart. So up here at the very top, I'm going to do insert, and then I'll do scatter plot, and then I'll plot points only. Now, this does not mean anything, so I'm going to click and I'm going to drag that graph into the box that it needs to be in, and there's two random points and things that don't make any sense, and I know that because it was a random graph. I just needed it on the paper. So now what I'll do is that I'll right-click with my mouse, and I will go down to this option that says Select Data. So when I go to Select Data, what this allows me to do is now tell it what I want it to individually plot. So what happens here is that I click on the Series 1. Series 1 are basically the 2 points that I've already determined, that I've already selected. I know those were bogus. I'm going to just remove those and start with a clean slate. I'm going to go up here to Add. And when I do that, I'm going to get a pop-up box. Here it is. And this pop-up box is going to say series name. I don't really ever name them. I mean, I guess I could, but I don't. And then it says, okay, well, what do you want to plot on the X and what do you want to plot on the Y? So in this box, I'm going to click, and there's my cursor. And these are the X values that I want that graph to plot for me. So using the control button, I'm going to hold it down on the keyboard. I'm going to click 50/50. Notice it went into that cell. 35/35, 20/20, 10/10, 05/05, 02/02, and 0. There we go. So I have chosen the X ordinance that I want plotted on this graph, and I did that individually. So on the Y value, there's something there. I'm just going to get rid of it. I keep the equal, but I'm going to get rid of whatever is there. And on the Y-axis, I'm going to do the same thing, and I'm going to do it in order. So I'm going to hold the control button down on the keyboard, and I'm going to click 13,420, 9305, 4722, 2476, 1173, 528, and 0. When I do that, I'll go up here to the top. Here's the pop-up box, Edit Series. And I'm going to hit OK. When I do that, that box disappears, numbers get filled into this cell, something happens, and I just hit OK again. And there is the graph that has now plotted my correct points, so that way I can do stuff with. All right. So now what we're going to do, we're going to plot an internal standard calibration curve, and we're going to do this the same way. Same motions, same everything. Except now for the internal standard curve, what we're going to plot for this one is actually going to be somewhat slightly different. The internal standard calibration curve, when I make these, concentration goes on the x-axis just as before. But on the y-axis, the regular calibration curve just took straight up area. That's all that it did. Well, here we did an internal standard, and the internal standard is a ratio. That internal standard was there, present in every single thing that we injected. That internal standard showed up. That internal standard had an area that was provided to it. We took the area of the ethanol, divided by the area of the internal standard. We got a ratio number, and that corrected for the auto-injector. If it injected too much one time, then we're compensating for that. If it didn't inject that much at all, or it was shortchanging me a little bit, we compensated for that one. All of those went through, and all of those were corrected and scaled accordingly based on the ratio number that we have to do with internal standards. So I'm going to do the calibration curve the same way, except now instead of plotting just the area average, I'm going to be plotting the ratio that we calculated from a previous video. So just as before, I do concentration and I'll click it. I'll hold the control button down and I'll click ratio. That gives me 2 points that I can quickly go up and just insert a chart, and I just want the points only. I'll click and drag this over, and there is something that I can start out with at least. I'm going to right click and I'm going to select the data manually. Whatever is there, remove it. That was from those 2 bogus points that I created. I'm going to add. The pop-up box happens again. So I'm going to click in the X value line, because that's what goes on the X axis. I'm going to hold the control button down, and it's 50-50, 35-35, 20-20, 10-10, 5-5, 2-2, and 0. Now I'm going to click in the Y axis box. Get rid of whatever is there, except for the equal sign. Hold the control button down again. That's what I'll do. And then click your ratio numbers in the same exact order. 2510, 1744, 966, 513, 233, 105, and 00. Now that those are there, I'm going to hit OK. Random stuff shows up. I'm going to hit OK. Oh no. What happened? Let's do this again. Look, I've said I don't get let down, and look at what happens. Sure enough, I get let down. Maybe I just accidentally pushed a button that I shouldn't have done. So we'll see. Hopefully this will work out. There we go. All right. So there are my points. That's kind of what I want to see. It looks like I actually forgot a number here. So let me do this again. It looks like I forgot to select the blank. So if I'm going to go back. Oh, what have I done? What have I done? I'm just going to delete all of this again, just so we can start fresh and clean. Doesn't that sound good? Fresh and clean. The only way to be in BAC. That even rhymes. All right. So the X values, again, 50, 50, 35, 20, 20, 10, 10, 5, 5, 2, 2, and 0. Look, oh my God, I'm putting them into Y. This is a sign. This is a sign of I need to stop recording videos all day long. That's what this is. All right. So the Y values are going to be here, 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 and here. And the X values are here, 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 and here. And then we hit OK. All right, so there's the chart. Again, it will take maybe a second or two for it to fill in, but give it just a moment and it should correct for itself. And, you know, both of these look like a pretty good straight line, and they should, honestly. You know, if I did my standard prep the proper way, those should go into a straight line, unless the auto-injector really kind of wonked out on me a little bit and caused my numbers to go off. And then, of course, the internal standard ratio should be a straight line as well, because we're correcting for the injections. So just like before, once I get these graphs, I now need to do a little bit of algebra. I need an equation that represents this straight line, and I need to see how straight of a line this is. So up here at the chart title, I'm just going to highlight that, and I'm going to put IS curve, which means internal standard curve. And then in this graph up above, I can click that chart title. I'll just go in and I'll put regular curve. So that way I know this is normally how we would do it. So if I click on a dot, it does not matter which. If I click on one of those points, all of them will get highlighted. So I'm going to now right click on one of those points. And then I add a trend line. This is going to add an equation onto our graph that we will need. So I'm going to display the equation. And I'm going to display the r squared value. The r squared value is how close to a straight line we actually are, and the perfect score is 1. So I'm going to click that checkbox, and we get a 0.9979. Pretty darn good, I think, for this group. So great job, folks, whoever you are. You did a really good standard prep. Almost a perfect score. All right, so then I'm going to do the same thing for the internal standard curve down here at the bottom. I'm going to click a data point. All of them highlight. And then I right click. Boop, and then I go to add trend line. Whee! And then I display the r squared and I display the equation. And oh my God, look at me. I get a 0.9997. So actually this really improved, right? 9979, and then it goes to 9997. So this linear regression line is much better. And again, that's the purpose of the internal standard. So what this is showing me is there was a little bit of error. There was some error assigned to the auto sampler because raw averages of the signals from the report, and in this case areas, those raw areas plotted to give me a pretty good straight line. I mean, I would feel really good about this, but I need to feel even better because the auto injector does a job and it's not perfect. So if we can correct for that, and that's what we did with the internal standard setup, we are correcting for those slight mishaps, and that allows me to feel even better about my standard prep because my regression line got even closer to 1, which means I'm better than what I thought I was. Good job, me! But I can't take the credit because I didn't make these standards. Another group of students did. So good job, you, whoever you are. And you might not know who you are because you probably won't be watching this video after you leave the class. So it doesn't really matter anyway, does it? All right, so now that we've got these two equations, I now need to go through, and that is the purpose of this section here in the spreadsheet. There are two y equals, one without the internal standard and one with the internal standard. So it just wants me to type in the values that I am getting from these graphs into the proper space. All right, so up here at the top, it's y equal, and I see y equal here. And I need to type in that cell, so I'm going to click it, 26603, and I hit enter. All right, so there's that number, and it says x minus. Well, this says x plus. So I don't want to change that x plus. I want to keep that template the same. So what I do here is that I keep the negative with the value, like this negative 9505. But I'm going to key in negative, which is just the minus key, 164.67. And then I hit enter. So that will enter that regression line or calibration curve line into the spreadsheet so I can do a little bit of math with it. Down here, I'm going to do the same thing, but this time with the internal standard information. So here's the internal standard curve. There's the y equals. This number is way lower, and the reason is because these are ratios. They're smaller numbers. So I'm going to key in 0.496 x. Now that's x plus, but we have a negative value here. It's a minus. So I'm going to keep that with the value. So negative 0.0006, and then I hit enter, And there we go. So there's the input of those two regression lines with R-squared values, one with a regular calibration curve and one with the internal standard version of the calibration curve. So we're getting a little bit closer. And the reason that we're getting closer is because I'm moving on to part C, and part C is now pertaining to the samples. So in the next video, we'll talk about how to handle these samples and what to do with them, what information to take away, and how do I finish up the calculations for the percent of BAC.